Good evening, everyone. So now we are going to discuss about our last unit, that is fifth unit, special semiconductor devices. Okay. So before going to discuss about the special semiconductor devices, so first we would like to revise our last class topics. So what are the last class topics? In our last class topics, so in our last class we have discussed about quartz crystal oscillators. Okay. So what is our last class? Quartz crystal oscillator. So here, what is the main element or basic element? Crystal is used. Okay. So why we are preferring crystal and what is the principle involved in the crystal is, the crystal is used to provide high frequency oscillations, and it works based on the principle of piezoelectric effect. How it works? It works based on the principle of piezoelectric effect. What is meant by piezoelectric effect? If we apply the mechanical pressure or force, it is able to produce mechanical vibrations. If we apply mechanical pressure or force, it is able to produce electric vibrations. If we apply electric charge across the plates, it produces mechanical vibrations and vice versa. So this effect is called what? Piezoelectric effect. Based on this principle, the quartz crystal works. And while coming to the crystal, under not vibrating condition, simply it equals to the capacitor separated by a dielectric medium. Means under no vibrating condition, crystal is equal to what? Capacitor. But under vibrating condition, capacitor is equal to RLC series circuits. So there C produces electric charge, L gives electricity, and R gives mechanical vibrations. And the quartz crystal oscillator circuit is very similar to that of Colpitts oscillator, except the inductor in tank circuit is replaced with the capacitor. So the tank circuit of crystal oscillator is simply like this. There are two capacitors are there, and in place of inductor it is placed with quartz crystal. But in Colpitts oscillator, the frequency is determined with the help of all tank circuit elements, inductor, capacitor 1 and capacitor 2. But here the frequency must be determined or depends only on the crystal. That's why it also called frequency determined network in the crystal oscillator. And more one topic also we discussed in our last class. What are the reasons for the instability of oscillations? What are the reasons we discussed? First one is called power supply variations, and second one is called temperature variations. Third one is called improper tapping of coils, and transistor parameter variations also there. So all these are the various reasons for the instability of oscillations, and low Q also sometimes, and high heat dissipation, temperature dissipation. And all these are the reasons to produce the instability in oscillations. And how can we avoid these variations? How can we protect our circuit from these disturbances? Those are called what? Remedies. What are the remedies to produce stable oscillation? So for us to, what is the problem? First problem is power supply variation. So without variations, how can we getting power supply? By using regulated power supply. So by using regulated power supply, also we can produce the stable oscillations. Second remedy is improper tapping of the coils will produce instability. So you tap it properly. And temperature variations also will affect. So to protect it from the temperature variations, provide proper shielding for the transistor. And transistor parameters also changed due to high heats. So you also use heat sinks. So these are the various remedies to protect the oscillator from the instability. And in our last class, we also discussed about more one topic. Those are the differences between LC oscillator and RC oscillator. While coming to the LC oscillator and RC oscillators, here in the tank circuit only inductor and capacitor are used. But in RC phase shift oscillators, resistor and capacitors are used. And while coming to the frequency, LC oscillator will produce high frequency and RC oscillator will produce low frequency. And while coming to the LC oscillators, it becomes somewhat stable compared to the RC. And in LC oscillator, high frequency is produced, resistor capacitor placed with inductor and capacitor. And while coming to the examples of LC oscillator, Hartley oscillator, Colpitts oscillator, single tuned oscillators are used. And in RC oscillator, Wien-Bridge oscillator, RC phase shift oscillators are the examples of RC. So these are the different topics we have discussed in our last class. So now we are going with special semiconductor devices. So what is our first special semiconductor device? Varactor diode. So see here the name itself indicates varactor diode means variable capacitor diode. So varactor diode indicate what's variable capacitor diode. So variable capacitance, varactor, variable capacitance means here the capacitance must be varied according to the properties of diode. That's why it is called varactor diode, variable capacitance diode. Why the diode acts like a variable capacitance? Why the diode circuit is equivalent to capacitance means? Simply first I would like to explain two things here. The transistor or the diodes are made with semiconductor materials, whether it may be PNP or NPN. So here we would like to explain about varactor diode. So that first I would like to give why it acts like a diode. So here it is P-type semiconductor and N-type semiconductor materials are attached together to produce the diode. But after some time, the depletion region will be developed. So cause of depletion region, what happened? The majority charges in the hole try to enter into the N region, but they not enter. And the majority charge carriers in the N region try to enter into P, but they are unable to enter. Cause of this depletion region. So simply this depletion region will oppose the flow of charge carriers from one side to other side. So it simply acts like a dielectric media of capacitor. Why? Because capacitor having two plates, these two plates are separated by a dielectric media, that is air. So here P is acts like one metallic plate, N is acts like other metallic plate, and this depletion region acts like a dielectric media. So this will oppose the flow of charge carriers from P to N and N to P. Means what here? Depletion region is equal to dielectric media and P is one metallic electrode and N is other metallic electrode. So in this way, one diode should be able to act like a capacitor. Based on that, the varactor diode is designed. So see here, this reverse biasing condition, why we preferred the PN junction in reverse biased for varactor diode means, in reverse biasing only we are getting much more depletion region. In forward biasing, width of depletion region is very less. Only in reverse bias condition we get more depletion region. Why? Because in reverse bias condition, P is connected to the negative terminal and N is connected to the positive terminal. So that majority is moved towards battery and minority is moved towards junction. In addition to the minority, mobile charge carriers, negative acceptor ions and positive donor ions also move towards junction. Cause of these negative acceptor ions and positive donor ions, the width of this potential barrier will be increased again and again. And finally it works like a dielectric media of capacitor. So that a reverse biased PN junction diode can be simply is equal to the capacitor. So see here, while coming to the slide, once check the slide. Here P and N regions are essentially low resistance areas due to the high concentration of majority charge carriers. In the space charge region, which is deflected of majority charge carriers, serves as an effective insulation between the P and N regions. And P and N regions acts as the plates of capacitors, while the space charge region acts as the dielectric media. So what is the equation for capacitance? C is equal to epsilon A by D generally, but here W indicates the width of potential barrier. So Ct is equal to what? Epsilon A by W. So W is the width of potential barrier. So Ct indicates total capacitance. A is the area of P and N regions. So this is the circuit of varactor diode. So what I explained, that is only there here. So it is made with PN junction diode. So here it is PN diode, it is the P region and it is N region. Okay, and when it is connected means P is connected to negative and N is connected to positive, so that the diode is under reverse biased condition. When the diode is under reverse biased condition, the majority charge carriers, these are holes, positive charge attracted towards the negative terminal. And in N region, majority charge carriers are electrons are attracted towards positive terminal. And finally, minority charge carriers move towards the deflection region. In addition to the minority charge carriers, negative acceptor and positive donors also move towards the deflection region. Is it clear? So this is the construction of what? Varactor diode. Simply it is made with a PN junction diode, and the PN junction diode is under reverse bias condition. P region is connected to the negative terminal and N region is connected to the positive terminal, so that all majority charge carriers move towards the battery. Minority and immobile charge carriers only move towards the junction, and these immobile charge carriers will form the deflection region. Cause of this deflection region, further minority charge carriers also not moved from one place to other place. Simply no current will be produced because of this deflection region. This deflection region acts like a dielectric media, and this P region and N region acts like a two metallic plates. In this way, the diode junction in reverse bias condition acts like a capacitor. So see here like this. Dielectric media is equal to deflection region, P region is equal to one of the capacitor plates, N region is equal to other capacitance plates. By increasing and decreasing the width of deflection region, capacitance must be increased or decreased. So like this. Why? Because capacitance C is equal to epsilon A by W. If width is increased, capacitance is decreased. If width is decreased, capacitance is increased. So like that, here it is a variable capacitor. Okay, why? Because it depends upon the deflection region width, the capacitance must be either may increased or may decreased. And see here, where epsilon is the permittivity of semiconductor material and A is the area of the junction, W is the width of space region. Already I told everything, but once check the slide. And W is the width of space charge region. The width W of the space charge region is approximately proportional to the square root of the reverse bias voltage VR. The area A and the permittivity epsilon being constant, we can write the equation 1 as Ct is equal to K by under roots VR. As the reverse bias increases, the space charge region becomes wider. This effectively increases the plate separation and decreasing the capacitance. So epsilon is the permittivity of semiconductor material, A is the area of the junction, W is the width of the space charge region, and the width of the space charge region is approximately proportional to the square root of the reverse bias voltage. So according to this, total capacitance Ct is equal to K by under root VR. As the reverse bias increases, the space charge region becomes wider, thus effectively increase the plate separation, so that capacitance will be decreased. See here, already explained working principle also, but once you have a look on slide. So see here, while considering a reverse biased PN junction diode, the depletion is informed between the P and N region does not have any mobile charge carriers. Mobile means moved majority, either electrons or holes. Simply it acts as an insulator. So P and N regions are essentially low resistance areas due to high concentration of majority charge carriers. Hence, they act as a conducting region. Now we observe the two conducting regions are separated by dielectric. Therefore, from the fundamentals of components of reverse biased PN junction acts as a capacitor. Is it clear? And the effective capacitance of the reverse biased PN junction is given by epsilon A by D. Ct is directly proportional to the 1 by Vr to the power of n. Ct proportional to total capacitance is proportional to 1 by Vr to the power of n. So here Vr is the reverse voltage. N is a constant value which depends upon the doping density. So n is equal to 1 by 2 for an abrupt junction and 1 by 3 for linearly graded junction. So here the value of n is constant. It is 1 by 2 for abrupt junction and 1 by 3 for linearly graded junction. Hence, by varying the reverse bias on the junction, the capacitance of the junction can be varied. Hence, by varying the reverse bias of the junction, the capacitance of the junction can be varied. So, this is the basic principle of the varactor diode. And see here, while coming to the characteristics of varactor diode. So, this is the curve that must be drawn in between reverse voltage and capacitance. So, in characteristics of varactor diode, we will draw the curve between VR and CT. So, here VR indicates the reverse voltage and CT indicates the capacitance. One second. CT indicate capacitance in picofarads. VR is the reverse voltage. And see here the graph shows graphically how the capacitance of varactor diode varies with the reverse bias voltage. So in the graph, the variations of capacitance is maximum when the reverse voltage is low. So capacitance is maximum when the voltage is low. If the voltage is increased, the capacitance is decreased. And it reduces in non-linear as the value of reverse bias voltage is increased. See here at 0 voltage, capacitance is maximum, reverse voltage. If reverse voltage is slowly increased, the capacitance is slowly going to reduced. That means simply it is following the vice versa nature. And our next special semiconductor device is construction and principle of UJT. So what is our next semiconductor device? UJT. So the name itself indicates UJT means uni-junction transistor. So why it is called uni-junction transistor means general transistor having two junctions, those are once have a look here, emitter base as well as emitter base collector. So in between emitter and base one junction is formed, that is emitter base junction, and in between base and collector more one junction is formed, that is called base and collector junction. So finally two junctions are there in PNP transistor, J1 and J2. But here it is a transistor, uni-junction transistor is also a transistor, but it having only one junction. That's why it is called uni-junction transistor. Once all of you observe the symbols. So see here in transistor three terminals are there, generally transistors are made with emitter base collector. But here the transistor is made with only two terminals, emitter and base. But here base is segregated into two names. Upper side is called base 2, lower side is called base 1. Finally it is only base. And it having one more terminal, that is called emitter. Instead of collector, here we are using base 2. But here collector is not there. Only base and emitter is there. So in between emitter and base only one junction is formed, emitter base junction. So that's why it is called what? Uni-junction transistor. So only one junction is formed between the emitter and base. So see here, an emitter is made with a p-type semiconductor and base is made with n-type semiconductor. Simply, first you would like to take an n-type semiconductor bar, then p-type semiconductor, heavily doped p-type semiconductor is injected into the n-type. How it is made means, first you would like to take an n-type semiconductor bar. Into n-type semiconductor bar, you introduce a heavily doped p-type semiconductor. A heavily doped p-type semiconductor. In this way, it having only two semiconductor materials, one is P like diode, one is N. But cause of base is segregated into two bases, upper and lower. Okay. So this is called what? Uni-junction transistor. Three terminals are there, cause of it is transistor, but among two terminals are same and only between two the junction is formed. That's why it is called uni-junction transistor. See here our slide also consisting of equivalent circuit of UJT. Simply while coming to the equivalent circuit, if we are connecting two resistors in potential divider form and you insert one diode across the potential divider network, so that is simply is equal to the uni-junction transistor. And whatever I said, that is there in the slide. What I would like to read here. What it consists? UJT. Okay, UJT consists of lightly doped n-type silicon bar. Two ohmic contacts are attached to this bar at the opposite end. So these ohmic ends are denoted as base 1 and base 2. So first you would like to take n-type silicon bar. At n-type silicon bar, two ends like this. This is n-type semiconductor bar. Here and here, at two ends, two ohmic contacts are attached to the two ends. And the two ends are called base 1 as well as base 2. Base 1 is indicated with B1 and base 2 is indicated with B2. And a point PN junction is formed at a point closer to B2 than B1. A PN junction is formed at a point closer to B2 than to B1. Now the terminal brought from this P-type material is called emitter. And the figure shows the circuit symbol of UJT. The arrow indicates the direction of flow of conventional current when UJT is forward biased. And see here the device is having one PN junction and 3 leads. It commonly known as unijunction transistor. Why? Because uni means single. With one PN junction, the device is really like a diode. Since two base terminals are taken from one section of the diode, this device is also called double base diode. Why it is called double base diode? How many number of bases are there? Two bases are there here. Two bases are there here. That's why it is called a double base diode. And the N-type region is lightly doped, but P-type region is heavily doped. Already I said all this. N-type is slightly doped and P-type is heavily doped. Means heavily doped P-type is inserted into the N-bar. Is it clear? And cause of P is heavily doped, N is lightly doped. The resistance between emitter and base 1 is more than that is between emitter and base 2. Is it clear? The resistance between emitter and base 1 is more than between emitter and base 2. And this is the circuit diagram of UJT. And see here, it is the simplified version shows that N-type channel consisting of two resistors RB2 and RB1. And these are in series with equivalent diode. So see here, D represents diode. D represents what? Diode. And the emitter PN junction is fixed along the ohmic channel during its manufacturing process. So the simplified equivalent circuit shows that N-type channel consisting of two resistors RB1 and RB2 in series with an equivalent diode, and here D representing the PN junction. The emitter PN junction is fixed along the ohmic channel during its manufacturing process. So see here, this is our circuit diagram. It is diode that is connected in between resistors RB1 and RB2, and this is supply voltage VDD, and this is supply voltage VBB. When the voltage must be applied across the diode, if the diode undergoes into the forward bias condition, it will produce some amount of voltage. Okay, if it is under reverse bias condition, it is unable to produce the voltage. See here, this is the equivalent circuit. Already I said this. If the potential divider network is made with resistors RB1 and RB2, into that circuit, if we insert diode at center point, then that makes the equivalent circuit of UJT. So see here, the variable resistance RB1 is provided between the terminals emitter base, and RB2 is between the emitter and base 2. Since the PN junction is more close to B2, the value of RB2 is less than the value of RB1. Why the value of RB2 is less than the RB1? Why? Because it is more close to B2. And here the voltage network is formed by the series resistances RB2 and RB1. When a voltage is applied across the semiconductor device, the potentials will be in proportion to the position of the base point along the channel. And see here the emitter will act as an input when employed in the circuit, as the terminal B1 will be grounded. The terminal B2 will be positively biased to B1. When a voltage applied across the terminals B1 and B2, when the emitter input is 0, the voltage across the resistance RB1 of the voltage divider circuit is calculated by VRB1 is equal to RB1 by RB1 plus RB2 into VBB. The emitter will act as an input when employed in a circuit. The terminal B1 will be grounded. But the terminal B2 will be positive biased to B1 when a voltage applied across terminals B1 and B2 when the emitter input is 0. So that VRB1 is equal to voltage across base 1 is equal to RB1 by RB1 plus RB2 into VBB. But VRB2 is equal to opposite resistance RB2 by whole resistance RB1 plus RB2 into VBB. And see here main important parameter of UJT is intrinsic standoff ratio. Main important parameter is what? Intrinsic standoff ratio. Okay. So here intrinsic standoff ratio lies in between 0.5 to 0.8. And how can we define the intrinsic standoff ratio? It is the ratio in between RB1 to RBB. And what is the value of intrinsic standoff ratio? 0.5 to 0.8. And when the PN junction is reverse biased, a small amount of voltage which is less than the voltage developed across resistance RB1 is applied across the emitter terminal. And see here, in this way, very high impedance is developed, prompting device to move into a non-conducting state. So what is meant by moving high impedance into the non-conducting state means it will be switched off and no current flow through it. And the UJT begins to conduct when the PN forward biased. When UJT begins to conduct when PN junction is forward biased. The forward biasing is achieved when voltage applied across emitter terminal is increased and becomes more than VRB1. The forward bias is achieved when voltage applied across emitter terminal is increased and becomes more than VRB1. And this results in larger flow of emitter current from emitter regions to the base region. So this results in what? Large flow of emitter current from emitter region to the base region. And increase in emitter current reduces the resistance between the emitter and base 1. So resulting in negative resistance at emitter terminal. And now the UJT will act also as voltage divider network or voltage breakdown network. When the input applied between the emitter and base 1 reduces below breakdown value, RB1 increases it to higher value. Is it clear? The UJT will act as voltage breakdown device when the input is applied in between the emitter and base 1. So the input between the emitter and base 1 reduces below breakdown value. Automatically RB1 is going to increase to the higher value. And this shows that RBI depends on the emitter current and it is variable. And see here, this is the diagram of characteristics curve of UJT. So this is a curve that must be drawn between current and voltage of UJT. So next axis we would like to take current. Next axis we would like to take current. Valley point this is peak point, and at y-axis you would like to take applied voltage. So when the voltage is applied, initially the current should be increased to the maximum value. After that it going to reduce due to the deflection region formed. Once the deflection region is break, again it would like to increased. Is it clear? So initially cause of applying voltage, width of deflection region will be reduced and the current would like to going to increase up to maximum value. So when it reaches the maximum value, that point is called peak point. That point is called peak point. So when it reaches to maximum value, cause of negative charge carriers immobile, deflection region is formed and the current is going to reduced. So when the current must be reduced, and by applying the voltage again and again, finally the deflection region will be broken and current is suddenly increased. So this point is called valley point and the region is called saturation region. At what point the current is suddenly increased cause of breaking the deflection region, that is called saturation region. And at what point it is suddenly increased, that point is called valley point. And while coming to the negative resistance region, so here by increasing the voltage, current must be reduced. So that it is called a negative resistance region. Current reduced means resistance increased. And here see here, while increasing the voltage, the current is suddenly increased from 0 point. So when it attains the maximum value, that is called peak point. When it attains minimum value, that is called valley point. So this is a simple explanation. This IV characteristics, current and voltage are VI characteristics consisting of three regions mainly. One is called cutoff region, other is called negative saturation region, and last one is saturation region. So this graph having three regions: cutoff region, negative resistance region, as well as saturation region. And cutoff region is the area where the UJT does not get sufficient voltage to turn on. Cutoff region is the area where the UJT does not get sufficient energy to turn on in the cutoff region, and the applied voltage has not reached the triggering voltage, thus making the transistor to turn off state. And while coming to the next one, negative resistance region, when the transistor reaches the triggering voltage, the unijunction transistor will turn on. After a certain time, if the applied voltage is increases to the emitter lead, it will reaches out at a V peak. The voltage drop from the V peak to valley point, even to the current increases, is called negative resistance region. What it is called? Negative resistance region. And more one region is there, that is called saturation region. So what is meant by saturation region means? Saturation region is the area where the current and voltage rises if the applied voltage to the emitter terminal increases. What is meant by saturation region? It is the region where the current and voltage rises if the applied voltage to emitter terminal increases. And while coming to the applications of varactor diode, means where it is used or where the varactor diode is used. See here, cause of its dielectric area is increased or decreased. This is used in tuned circuits. In our previous classes, we have discussed about tuned amplifiers now. So like that, the varactor diodes are used in tuned circuits. And these varactor diodes are also used in FM modulators. So here FM means frequency modulation modulators. And these varactor diodes are also used in automatic frequency control devices. Okay, and in adjustable band pass filters. And also varactor diodes are used in parametric amplifiers and television receivers. So what are the applications of varactor diode? These are used in tuned circuits, and these are used in FM modulators and also used in automatic frequency controlling devices, and also used in adjustable band pass filters, and used in parametric amplifiers, and also used in television receivers. And also used in switching devices, and the triggering device for trikes and SCRs, and also used in timing circuits, and also used for phase control in sawtooth generators. So these are the wide variety of applications of UJT. Finally, it is also used in relaxation oscillators. Okay, so in today's class, what we are discussed, tell me. Our unit name is special semiconductor devices. Why it is called special means normal semiconductors are p-type and n-type semiconductor. If we made any device with p-type and n semiconductors by attaching, those are called diodes and transistors. But in addition to the diodes and transistors, with the help of semiconductor materials, we also made capacitor, potential network form. So all these are the applications of PN junction diodes. So these are called special semiconductor devices. And in today's class we are mainly discussed about varactor diode. Varactor diode means variable capacitor diode. When a diode works as a varactor diode means if the diode is under reverse bias condition, simply it works like a variable capacitor diode. Why? Because means under reverse bias condition, the width of deflection region is very high. It simply is equal to the dielectric media, and it will oppose the flow of electrons from N to P and P to N. Okay, so these are the different topics we are discussed in our class. While coming to the questionnaire, the long answer questions are explain the construction and operation of varactor diode, and explain the operation of unijunction transistor, or sometimes they also ask like explain the characteristics of UJT. Explain means you draw the VI characteristics and you explain about cutoff, saturation and negative resistance region. And sometimes they also ask draw the characteristics curve of UJT. And here one mark question is very important. State or define the intrinsic standoff ratio. And also they sometimes ask give the value of intrinsic standoff ratio. Give the value of intrinsic standoff ratio. Or define the intrinsic standoff ratio. How it is indicated. These are short answer questions. So while coming to the long answer, they only ask about constructions and operations with neat sketches you write. And while coming to the varactor diode, so this varactor diode acts for 5 marks question, but draw the symbol of varactor diode or draw the symbol of UJT is 3 marks questions, and characteristics are of also 5 marks questions. Applications, advantages, disadvantages, all these are 3 marks questions. Okay, so but here the applications of UJT is very important. You must focus on applications. Why? Because sometimes they also ask these applications for 5 marks question. That's why you must and should learn at least 10 apps for the UJT. Where we are using UJT, at least you learn 10 apps, then it is very easy. Okay. So 1 mark question is state intrinsic standoff ratio, and 3 marks are advantages applications, 5 marks are constructions and operations with need sketch, and also the characteristics are comes into the what? 5 marks question. So this is about today's class. Now I would like to finish the session. In tomorrow's session we will meet you again.